Welcome to the last module of this unit 1. Well, we have up till now studied about arithmetic progressions and geometric progressions in the previous module, and we have solved some problems as well. Now in this module, let us do some problems which are applied to various fields, mostly in management. So we will be doing those problems which are applicable in management field. Let us now start the problems. Let us read the first problem. The problem states that a person was appointed in the pay scale of rupees 700. Now this is 40 is the increment, 1500 this is the pay scale that he is fitted into. It means that if he starts with rupees 700 rupees, every year there will be a 40 rupees increment till he reaches 1500. Find in how many years he will reach the maximum of the scale. So the maximum of the scale is 1500 rupees. So that is the maximum he will reach. So we will have to find in how many years he will reach the maximum of the scale. This problem is typically a arithmetic progressions problem. Here our initial term is 700. This is the initial salary that this person is drawing. So I can say A is equal to rupees 700. Then what is the common difference? The common difference here is 40. So the common difference D is equal to 40. What is the final salary that he has to reach? He has to reach 1500. In how many years? That is the question for us. So let the number of years is unknown to us. Let it be n number of years. Let him reach in n number of years, n. So he will be reaching 1500. So now we have your Tn is 1500. What is the formula for Tn in arithmetic progressions? We have Tn is equal to A, the initial term, plus n minus 1 into D. Let us substitute the values on this and see. 1500, Tn is 1500 is equal to A is 700 plus n minus 1 into D. D is 40 here. Let us solve for n. That is the question asked for us. Now I transpose this 700 onto this side, then we get 1500 minus 700, that gives me 800 is equal to n minus 1 into 40. So n minus 1 is equal to 800 by 40, which gives me 20. So n is equal to 20 plus 1, transposing this 1 to other side, we have 21 years. So hence he will reach the maximum of the scale in 21 years, because his pay in 21 will be A plus 20D, that is the 21st term. So he will be reaching his salary of 1500 after 21 years. So this is how we apply arithmetic progressions to the salary type of problems. Now let us go to the next problem. So now we are typically solving the applications of arithmetic progressions applied to the various management fields. Let us see another problem now. The problem is, I read the problem here. The gate receipts at the show of a film amounted to rupees 6500 on the first night and showed a drop of rupees 110 every succeeding night. If the operational expense of the show are rupees 1000 a day, find on which night the show ceases to be profitable. Now the problem is very simple. We need to understand various terminology in this particular problem. Now this is about a film show, and the gate receipts of the show of a film amounted to 6,500 on the first night. It means our first term is 6,500. Then this showed a drop of 110 every succeeding night. So every succeeding night it is showing a drop of 110 in the collections. It means the common difference is 110. So let me write here, A, the initial term is 6,500 and the common difference D is 110 minus 110, because there is a drop, it decreases. So the common difference is minus 110 in this case. Then if the operational expenses of the show are 1,000 a day, find on which night the show ceases to be profitable. It means to run the show the operational expenses is 1,000. So it will be not profitable for me to continue with the show if my collections are less than 1,000 rupees. I will continue with the show as long as my operational expenses are covered. So here I need to get at least a minimum of 1,000 rupees. If the collection goes below 1,000 rupees, it is not profitable for us. So here I can say that the final collection can be 1,000. It means Tn, n is the period which is not known to us, and that is what we are going to calculate. Tn is 1,000. The problem is now very simple. You know the formula, Tn is equal to A plus n minus 1 D. Let us solve this problem. Here 1,000 rupees is equal to A. A is 6,500 plus n, the period is not known to us, we are calculating this, into D. D is minus 110. Why minus? Because the collections are getting decreased. So this is 6,500 minus 110 n plus minus into minus is plus 110. So this amounts to 0,166. Transposing this to this side, it is 110 n. Taking this 1,000 to this side, it is minus 1,000. So this is 5,610 110 n. So the value of n is 5,610 by 110, which gives me 51. So on the 51st night the show will cease to be profitable. Why? Because my collections are going below the operational expenses of 1,000. This is an application of arithmetic progressions. Let us now proceed to the next problem. Let us move to the other problem. Now this is a problem based on hospital attendance. This is also an application of arithmetic progression. Let us now understand what the problem is. On the first day of the strike of the physicians in a hospital, the attendance of the OPD, outpatient department, was 750 patients. As the strike continued, the attendance declined by 50 patients every day. Find from which day of the strike the OPD would have no patients. So what's happening? Because of the strike of the physicians, the attendance of the outpatient department was coming down. Initially the attendance was 750 patients, and the day by day it is declining by 50. So we have to find from which day of the strike of the OPD there will be no patients. So ultimately no patients means nil, 0 patients. This is a problem similar to the previous problem. Let us now understand. Let us do the problem. So we know that Tn is equal to A plus n minus 1D. This is the formula known to us. And what is A in this case? A is the initial number of patients, which is 750. And what is Tn? Tn is nil patients. So we need to have 0 patients here. Plus n is the number of days which we are going to calculate. and D. D is declining by 50. When we say decline, the common difference is minus 50. Minus 50. Now let us calculate this. Yeah. 0 is equal to 750 minus of n minus 50n minus 50 into minus 1 is plus 50. So 50 plus 750 is 800. Bring this 50 to this 50n onto this side. We have 800, and then n is 800 by 50. So that gives me 16. So on the 16th day of this strike, the OPD will have no patients, and that is the problem is all about. So that is how we solve problems using arithmetic progressions in our business management decisions. Let us now move to the other problem now. Let me read the problem for you. Firm A begins production with 1000 units per year and decreases its production by 100 units per year. Firm B starts with 500 units and raises production by 25 units per year. Question number 1. There are 3 questions to this problem. Question number 1. When will be the production of firms A and B equal? 2. When will the production of firm A decline to 0? 3. What will be the production of B in that year? So now let us start the problem. Well, what is the question in the first? When will be the production of firms A and B equal? So let us assume that after n years the production of A and B are equal. Let me start the problems. Firm A begins the production with 1000 units. So after n years the production of A will be initial units is 1000 and n is the number of years, n minus 1, and D, it begins its production and decreases its production by 100 units. I told you when it's decrease we have to take the common difference as minus 100. Now this should be equal to the production of B after n years. That is the condition given in our problem. Firm B starts with 500 units. So it is 500. This is for B. This is production for B. 500 plus n years, and it raises its production by 25 units per year. It means the common difference is plus, because here there is a raise or an increase. So here in this case this is 25, and solve for n now. 500 when I transport to this side it becomes 500, 1000 minus 500 is 500, this is minus 100n, this is plus 100, and on this side I have 25n minus 25. Let me transpose this to this side. So I am transposing all the terms to this side, take n to that side, it becomes 125 n, 100 minus 100 n plus 25 n is 125 n, and this will be equal to 500 plus 100 is 600, 600 bring this 25, it becomes 625. This implies that n is equal to 625 by 125. So this is 625 divided by 125. This gives us a value of 5. So after n years the production of A as well as the production of B will be equal. That solves our first problem. What is the second problem now? when will be the production of firm A decline to 0? So, here it means that let us assume that in n years the production of A will decline to 0. The production of A in n years is, we are solving the second one, 1000 plus n minus 1 into minus 100 should be equal to 0. Let us solve for n in this case. This is 1000 minus 100n, minus into minus is plus, this comes to plus 100 is equal to 0. This implies that transposing this 100 to other side, it becomes 100n is equal to 1100, or n is equal to 11. So, the production of A, production of firm A will become 0 after 11 years. That solves our second problem now. Let us read the third problem. What will be the production of B in that year? In which year? In the year of 11. In that year means he is referring to the n is equal to 11. Let us solve this now. Production of B in that year. So, production of B in that year will be, this is the third problem we are solving now. Production of B will be 500 plus, what is n in this case? N we have to take as 11. So, this is 11 minus 1 into 25. So, this amounts to 10, 11 minus 1 is 10 into 25 gives me 250, 500, and this is 750 units. So, 750 units. The production is always in units. So, in 11 years the firm B will yield 750 units. So, this is how we have many applications of arithmetic progressions in management problems. I hope you have understood. Having learnt the practical applications of arithmetic progression, now we will move into practical applications of geometric progressions for various management decisions. Let us read the problem now. The inventor of the chessboard suggested a reward of 1 grain of wheat for the first square, 2 grains of wheat for the second, 4 grains for the third, and so on, doubling the amount of grains for the subsequent squares. How many grains would have to be given to the inventor? There are 64 squares in the chessboard. We know that there are 64 squares in a chessboard. So, now this inventor of this chessboard, he is asking for 1 grain in the first, to be put in the first square, double that amount of grains, that is 2 in the second square, double again in the third, that comes to 2 into 2 is 4. In the fourth one it comes to be 2 into 4 it becomes 8, and then subsequently it is 16, and so on. So, now how many terms are there? Totally there are 64. So, let us find the number of grains that are required to fill this chessboard. A very interesting problem now. Initial, let us see the series now. The series becomes 2 plus 4 plus 2 times, again 2 times, again 2 times, again 2 times, so on till your 64th term. This is the problem. Now, you have to recognize whether this is an arithmetic progression series or a geometric progression. Here very clearly we see that the common ratio is 2 because there is a multiple of 2 here. So, here R is equal to 2, A is 1, N is 64. So, you have to find S 64, the sum to all these squares. What is the formula? The formula is Sn is equal to A into R to the power of n minus 1 by R minus 1. We have discussed this in the previous module. This gives me 1 into R is 2 to the power of 64 minus 1 by 2 minus 1, or this is 2 to the power of 64 minus 1. You will require 2 to the power of 64 minus 1 number of grains to fill the chessboard. That's the interesting problem here. Let us now move to another problem. Now we have to identify whether this problem is an arithmetic progression problem or a geometric progression problem. Let us now proceed. Let me read the problem for you. It starts like this. 150 workers were engaged to finish the job in a certain number of days. 4 workers dropped out on a second day. 4 more workers dropped out on third day, and so on. It took 8 more days to finish the work. Find the number of days in which the work was completed. So the work was started by 150 workers. Now if the work had happened with all the 150 workers, it would have taken n number of days. But what is happening here? Every day 4 workers are dropping out. Now we will have to find how many number of days this work will be completed now. So let us now, it took 8 more days to finish the work. So we have to find the number of days in which the work was completed. Now for 150 workers, took n days. So for one day, how much work will be done by these 150 workers? For one day, work done by 150 workers will be 1 by n. This will be in one day. So one worker, it means that one worker can complete how much of work? 1 by 150 n in one day, in one day. So 150 workers will complete 150 into 1 by 150 n, which comes to 150 by 150 n of the work. Now it is now said that on the second day 4 workers drop. When the 4 workers drop, what is the work? How many workers are now left out? 146. So 146 workers second day will complete 146 by 150 n of the work. On the third day, now on the third day, again 4 workers drop out. We have only 142 workers, and they will complete 142 by 150 n of work. So in this manner, the work was finished in n plus 8, because it took 8 more days, n plus 8 days. Had 150 workers worked, it would have taken only n days, but that 4 members are getting dropped every day. The work continued for another 8 days, and the total number of days is n plus 8. So now let us construct the series. The series is 150 by 150n plus 146 by 150n plus 142 by 150n, so on till n plus 8 number of days or terms, and then the whole work is finished. It is 1. The whole work, the number of terms will be n plus 8 terms. Now, very clearly we can see that this is an AP. This is an arithmetic progression. What is common in all of this? 1 by 150n. I take that as common, and this becomes 150 plus 146 plus 142 plus so on till n plus 8 terms. N plus 8 terms. This is equal to 1. So, when I transpose this 150n to other side, I have 150 plus 146 plus 142 plus so on till n plus 8 is equal to 150n. Now, when we look at this series here, clearly there is a decrement of 4, minus 4 for every succeeding step. It means that this is a AP, arithmetic progression. So, we know the sum to n terms of a arithmetic progression is n by 2 into 2a plus n minus 1d. Let us apply that formula. Here the number of terms is n plus 8. So, n by 8, n plus 8 by 2, n plus 8 divided by 2 into 2 into the first term, which is 150 plus n minus 1. N here is n plus 8 number of days, please remember that, minus 1 into d. Here d is, for me, it is minus 4. This is equal to 150n. We have to solve for n. This gives me n plus 8 by 2, 300 plus n plus 7 into minus 4 is equal to 150n. Let us solve this now further. This comes to n plus 8 into 300 plus, minus into plus is minus 4 into n plus 7. Taking this to the other side, it gets multiplied here. 150 into 2 is 300n. This is n plus 8, 300 minus 4n minus 28 is equal to 300n. So, this gives me 2176 240n minus 4n square is equal to 300n. I get an equation. On solving this, n square plus 15n minus 544 is equal to 0. On solving this, we get n plus 32 into n minus 17 is equal to 0. So, n is equal to 17 or minus 32. We will discard the negative value and take n is equal to 17. So, the number of days to complete is n plus 8, please remember that, n plus 8, that gives me 17 plus 8, which is 25 days. Typically, these are the problems that we encounter in day-to-day management. So, we have successfully journeyed over this unit 1 statistics. We have covered statistics in business and management, arithmetic progressions and geometric progressions and their applications in day-to-day business management. I am sure you will be confident with all these modules in unit 1. See you. This is Kameswar Rao signing off for you. Thank you and all the best.